Hello, here's my report for Lab 3, Magnetic Field of a Bar Magnet. Let's outline the goals and concepts behind this lab. So this lab essentially asks us to measure the distance dependence of a magnetic field due to a small bar magnet and to compare it to a computational model based on the Biot-Savart law. The main concepts covered are of course the Biot-Savart law, the Earth's magnetic field, and the distance dependence of the magnetic field. On the right, you can see the Biot-Savart law for the magnetic field of a current element. Let's examine the experiment. Now, the experiment essentially asked us to measure the magnetic field at various points around the bar magnet and to plug in the data in the given spreadsheet. Using this data, we actually calculated the distance dependence, which in this case is the coefficient of x in the given equation below. We can clearly see that this is equal to approximately -3, which would mean a correlation of 1 over r cubed. Using this, we actually calculated the magnetic moment due to the bar magnet using standard formulas. According to my calculations, the magnetic moment due to this bar magnet, mu, was approximately equal to 2.2 amperes meter square. In this experiment, as I explained before, we were asked to measure the magnetic field at points around the magnet, which was done using a phone and the phone's magnetometer. Now, the experiment was set up as prescribed, and the following values were computed, which are as given. What I found out was that the average distance of 0.283 meters, the average magnitude of the magnetic field was approximately 1.11 into 10 to the negative 5 Tesla. This slide shows us the computational model that was based on the starter code given in the lab, which was used to calculate, using the Biot-Savart law, the magnetic field magnitude at the particular distance that I measured it at. Now, the output from the computational model suggests that the B net value is 1.52 into 10 to the negative 5 Tesla, which is very close to the experimental value of 1.11 into 10 to the negative 5 Tesla. And this minor error can be attributed to various factors which were described in the lab experiment itself. The output of this is shown to the right. The experiment called for these questions to be answered. Hence, what if you hadn't oriented your experiment to compensate for magnetic north and had instead laid out your meter stick at some intermediate angle with respect to the Earth's magnetic field? How would your results have changed? The results would have been skewed by Earth's magnetic field, causing the calculated values to be far from the expected ones. What if you were to stick two identical magnets together, end to end, and run the experiment again? How would you expect your measurements to differ? The values of the experiment magnetic field would double.